afternoon, good evening. Thank you for joining us in this very first tinyML Technical Forum Asia. My name is Wei Xiao. I'm from ARM Machine Learning Ecosystem. It's my huge pleasure to be on the technical program committee of tinyML Asia. So our first poster is from Weiwen Jiang, who is the PhD postdoc research associate from University of Notre Dame. He will introduce from cloud to edge a road of network accelerator co-design for high accuracy and energy efficient AI solutions.
Hello everyone, my talk is about the road for network and accelerator co-design for high accuracy and energy efficient AI solutions. In the following, I will represent a review of our co-design work carried out through these years. And these works are aiming to pushing forward the AI democratization from cloud to edge computing. And these works are conducted by University of Notre Dame and collaborated with 8 colleagues. We are now entering the AI democratization era. Intelligence is going to different computing scales, such as the large-scale cloud computing, the middle-scale edge computing, and the small-scale sensor networks. Different scales have totally different requirements. For instance, the cloud computing scale requires the highest accuracy. Many edge devices require real-time performance, and the sensor network require extremely low power. As a result, no uniform AI solutions can work for all scales. Now let's narrow down to one scale, taking the edge AI as an example. And showing this slide, even for one scale, there are so many different application scenarios. In addition, there are so many different types of computing resources to build up our today's computing system. Therefore, with the uniform real-time requirements, each hardware further needs a specific AI solution. This slide demonstrates the progress of the AI democratization conducted throughout these years. First, the manually design is performant. In the second step, the network is automatically designed for the cloud and the server without hardware constraints. Then, mobile platform is considered to involve the latency into consideration. Finally, the core design of neural network and the customized platform was proposed for higher performance and lower energy efficiency, which is consistent with the concept for tiny machine learning. Now, let's review the progress of the neural network design. At the early stage, the network is manually designed. At this stage, the design is really time-consuming and involve a lot of expertise. And showing the slides, for the ImageNet data sets, it will almost take 1 year to evolve to another type of network for higher accuracy. In 2016, the automatic neural architecture search was proposed to build a highway to identify networks. It is based on a search loop demonstrated in this slides, which is based on the reinforcement learning approach, and the RNN controller will control the whole procedure. There are 2 limitations of the initialized work. First, the search process is very inefficient. It takes hundreds to thousands GPU hours for the search process. Second, the identified network is too complicated and only works for cloud computing with enough computing resources. The inefficiency was solved by the differentiable neural architecture search. And but for such kind of network architecture search, it still cannot be directly applied for the tiny machine learning. In 2018, the latency-aware neural architecture search is proposed, which is targeted on the mobile platform. It takes the latency into consideration during the search loop, which enable the finally identified the solution to guarantee to satisfy the timing constraints. To further improve the efficiency, other kind of hardware accelerator designs was proposed, but there is a missing link between the design space of neural architecture search and the design space of the hardware. To close this game, we proposed the first core design framework, FNAS, in 2019. The framework is named FNAS. It can simultaneously explore both spaces. Recently, other types of search algorithms, such as evolution and also the differentiable neural architecture search was proposed to accelerate the search process. In this year, we further proposed NAS and ASIC NAS to further reduce the energy consumptions. As we all know, ASIC can have much better energy efficiency, but the most challenging problem is the core design of ASIC has a huge design space. In our deck work, collaborating with Facebook, we propose the template-based new architecture search, which can shrink the design space and have a much more better performance. Finally, we further propose the framework to co-design neural network and computing in memory architecture. And it is expected to have much lower energy consumption and which can be applied for the tinyML. So here's the information of the speaker, and also here is a list of our selected publication. Thank you for your watching.
Any questions for our presenter? First one, can you talk about your latency prediction?
Right. I think this is a good question, and this depends on the target computing platform. For example, if you are using the FPGA, actually we propose a validated performance model, so that if you're given the inputs, such as the size of the inputs and the model itself, we can give you, we can output the latency for the prediction. And for the mobile phones, and as far as I know, I think they predict they created the cycle accurate simulator to obtain the latency. And also for the ASICs, there are a lot of existing tools that can be used for the latency prediction. The one that we used in our work is called let me think, what's the name of it? It's a tool developed by the Georgia Tech, so that I think you can. Oh, it's Meso, right? Okay, it's Meso. So that you can directly use that. If you give the data flow of your application and also the input size, it will let you know the latency as well as other hardware information like the energy consumptions as extra. Okay, I think this depends on the platform, and thanks for the question.
Cool. Somebody is asking if you have a personal website.
Okay.
Research you can share with us. Yeah.
Yeah. Actually, I have one. It's just wjiang.nd.edu, and I can put it on the chat.
Yeah.
Or I can answer it on the Q&A.
Yeah, probably you can address the question directly in the Q&A window, so everybody will be able to see that.
Sounds great.
Cool. Thank you. We would love to thank our sponsor again to make this event possible and free of charge. So ARM, who provides the software and hardware solutions for tinyML development, we rolled out M55 and U55 micro NPU early this year. And a couple of weeks ago, we rolled out the second generation of micro NPU U65. So if you want to learn more, you should be able to find information in our VIP package. Edge Cortex provides dynamic neural accelerator architecture and co-exploration engine that brings cloud-level performance to the edge. SynSense builds ultra-low power sensing and inference hardware for embedded, mobile, and edge devices. And thank you, our partner organization, Shan, as our conference partner, and our media partners listed on this page. You will find them on our tinyml.org website. So again, thank you for joining us today. This concludes our last day of tinyML Asia 2020. We hope you learned something new in this week, and we hope to see you next year. So please visit tinyml.org for more information. The slide deck and the videos will be posted shortly.